So I have two aims for my talk today. The first aim is to look at the core historical insights from the science of categorization, particularly Eleonore Neufeld's seminar, Principles of Categorization. And second, to ask what some of the lessons are we can draw from these insights about, on the one hand, social concepts, and on the other hand, the implementation of conceptual engineering projects of social concepts. So a small disclaimer, this is very much work in progress. In fact, it's hot off the press. I just finished writing the first draft of it yesterday night. So I'm particularly looking forward to any sort of feedback, recommendations, and so on. And of course, super excited to be able to have the opportunity to present this here to experts on the implementation challenge. So I want to start off by introducing or by presenting you with a certain taxonomy. So it's Jorge Luis Borges' fictional animal taxonomy in Celestial Emporium of Benevolent Knowledge. So here's the taxonomy, or here's what he says. On those remote pages, it is written that animals are divided into those that belong to the emperor, embalmed ones, those that are trained, suckling pigs, mermaids, fabulous ones, stray dogs, those that are included in this classification, those that tremble as if they were mad, innumerable ones, those drawn with a very fine camel's hairbrush, others, those that have just broken a flower vase, those that resemble flies from a distance. Now, what's remarkable about this taxonomy is that it does not exist. We have no lexicalized terms that pick those categories out. These categories aren't codified in this way. Why not? Eleonore Roche gives an answer to this question in her seminar paper, Principles of Categorization from '78. And what she says there is that human categorization is not arbitrary. Instead, two psychological principles constrain possible systems of classification for all human cultures. Now let's have a look at the principles, specifically at, I think it's particularly useful to look at the principles as Rush formulated them. So let's look at the first principle, the principle of cognitive economy. Here's what she says about it. The first principle contains the almost common sense notion that as an organism, what one wishes to gain from one's categories is a great deal of information about the environment while conserving finite resources as much as possible. To categorize a stimulus means to consider it, for the purposes of that categorization, not only equivalent to other stimuli in the same category, but also different from stimuli not in that category. On the one hand, it would appear to the organism's advantage to have as many properties as possible, predictable from knowing any one property. A principle that would lead to the formation of large numbers of categories with as fine discriminations between categories as possible. On the other hand, one purpose of categorization is to reduce the infinite differences among stimuli to behaviorally and cognitively usable proportions. It is to the organism's advantage not to differentiate one stimulus from others when that differentiation is irrelevant to the purposes at hand. Okay, so what can we extract from this? First of all, there seems to be the principle of cognitive economy exemplifies, brings out a compromise that has to happen between two pressures that underlie the category system. On the one hand, we have an information pressure, namely to get as much information out of concepts as possible. But on the other hand, we have cognitive scarcity, which pressures us to preserve cognitive resources. Now, the pressure for information makes our concepts extremely useful. But in its limit, it would lead us to form the most specific concepts possible, even if we don't gain very much through the increasing specificity. So the pressure to preserve cognitive resources pressures us to make concepts distinctive as to limit their number and processing costs. So in short, the conceptual system works better with a few fairly informative concepts rather than a very large number of extremely informative concepts. Okay, so this was the first principle. What's the second principle? Second principle is the principle of perceived world structure. And here again is what Roche says about it. The second principle of categorization asserts that unlike the sets of stimuli used in traditional laboratory concept attainment tasks, the perceived world is not an unstructured total set of equiprobable co-occurring attributes. Rather, the material objects of the world are perceived to possess high correlational structure. That is, given a knower who perceives the complex attributes of feathers, fur, and wings, it is an empirical fact provided by the perceived world that wings co-occur with feathers more than with fur. And given an actor with the motor program for sitting, it is a fact of the perceived world that objects with the perceptual attributes of chairs are more likely to have functional sit-on-ableness than objects with the appearance of cats. In short, combinations of what we perceive as the attributes of real objects do not occur uniformly. Some pairs, triples, etc. are quite probable, appearing combinations sometimes with one, sometimes another attribute. Others are rare. Others logically cannot or empirically do not occur. So again, what can we extract from this? What Roche does is just to point to a simple fact about the perceived world, namely that some properties in the empirical world correlate and others don't. Now, the perceived world, therefore, comes as structured information, as specific bundles of co-occurring features, rather than as arbitrary or unpredictable features. So information-rich bundles of perceptual attributes form natural discontinuities. And together with the first principle, we can use these discontinuities in categorization to make cuts along these discontinuities. Okay, so here the summary is just very short, summarized. The principle of cognitive economy says that the task of a category system is to provide maximum information with the least cognitive effort. And the principle of perceived world structure says that the perceived world comes as structured information rather than as arbitrary and unpredictable attributes. Now, importantly, there are certain implications of the principles. They imply that not all ways of categorizing the world will be equally useful. Particularly the so-called basic level of categorization, which is the most inclusive level of categorization at which objects in the class share a high number of common and distinctive attributes, will be the level of categorization that maximizes cognitive efficiency while keeping predictive value high and tracking the perceived environment. Now let's look a little bit more at what this means and what the basic level of categorization is. So here's my dog, Pico. You might hear him bark in the background. And we can categorize him along in multiple ways, some being more general and some being more specific. So we can categorize him as object, animal, mammal, dog, terrier, American Pit Bull Terrier, and so on, where this list is ordered according to the inclusivity of the category, where object includes very much and American Pit Bull Terrier much less. Now, the category dog here is the basic level category, or is often used as the basic level category. Because when you looked at my dog, you probably immediately, or the first categorization you had in mind was probably dog. And this primary mode of categorization, or this primary level of categorization is what psychologists call the basic level category. And as you notice, it kind of stands in the middle of this hierarchy we have here. The levels that come above the basic level category is the superordinate level category, and the levels that are below are the subordinate level categories. Now, here we can look at it as an organized taxonomy, where we have categories such as mammal and fish as superordinate categories, deer, dog, trout, and shark as basic level categories, and terrier, spaniel, and rainbow trout and brown trout as subordinate level categories. Now notice a couple of features of these three levels. If you look at the superordinate level, notice that mammal and fish, that these categories are extremely distinctive. Mammals don't have much in common with fish. However, each category isn't very informative. If I tell you that something is a mammal, you can't extract all too much information from that. Why? Well, because all sorts of categories fall under the category mammal. All sorts of things fall under the category mammal that don't have much in common with each other. The basic, the subordinate categories are very informative. I can extract a lot of information from knowing that something is a terrier. However, the categories are not very distinctive. Terriers and spaniels are very much alike each other. Now, the basic level categories seem to be both informative and distinctive. Deers are very different from dogs. At the same time, from knowing that something is a dog, you can extract a lot of information from it. You can know that it barks when someone rings the doorbell, that it has 4 legs, that it's furry, that it's cute, and so on and so forth. Now, the first person who noticed that the basic level category seems to be somehow advantaged in categorization, or seems to come with a special advantage, was arguably Brown, who notices here the dog out on the lawn is not only a dog, but it's also a boxer, a quadruped, an animate being. It is the landlord's dog named Prince. How will it be identified for a child? Sometimes it will be called a dog, sometimes Prince, less often a boxer, and almost never a quadruped or animate being. So this points to this basic level advantage that later on a lot of psychologists identified. So Rush and colleagues found in multiple experiments that basic level categories are psychologically privileged in multiple ways. Here are just some of these ways. For example, in naming tasks of pictures, people almost exclusively use the basic level term. For example, they identify a picture as a tiger versus and not as a Bengal tiger or a mammal, or they identify a picture as a table and not as a kitchen table or furniture, and so on. In feature listing tasks, participants list substantially more features for the basic level category than superordinate categories, and only slightly more for subordinate categories. The same applies when asked to list what kind of movements you do when interacting with an object. Basic level terms come first in language acquisition of children, and so on. Now, why are basic level concepts so special? The explanation that is given almost everywhere in the literature is the so-called differentiation explanation, which in other words just says or expresses that they follow the principles of categorization. What is the differentiation explanation? Well, basic level concepts are the only ones that are both distinct and informative, as we just saw when I showed you the organized taxonomy. From knowing that something is a dog, we can infer a whole lot from it because there's high in-group similarity. But at the same time, dogs are quite different from other categories. So quite different from elephants, giraffes, tigers, rats, cows. Now, differentiation is an advantage exactly for the reason the principles are useful, namely that we get a great deal of exactly for the same reason the principles of categorization are useful, namely because we get a great deal of information out of basic level concepts while minimizing the use of cognitive resources. And in support of this, when you display participants with categories, artificial categories that you come up with in the lab, or natural categories that are really used in natural categorization, and you know of them that they display both high distinctiveness and high informativeness, the participants display the same effects as in basic level concept experiments. So concepts that you independently know are highly distinct and informative will be treated as privileged by participants. Okay, now that we know the background, I want to draw some lessons out of them. So now is the part where I want to draw two lessons out of that for conceptual engineering projects of social concepts and the implementation of those projects. So first of all, what do I mean by conceptual engineering? I just operate with a psychologistic and practical aim understanding of conceptual engineering, where psychologism, here I take the formulation of Koch, says that to engage in conceptual engineering is to advocate and implement changes in how people use words, classify objects around them, and draw inferences about those objects. Perhaps unsurprising that I operate with this understanding. And the practical goal approach to conceptual engineering says that, again, from Koch, conceptual engineers sometimes aim to change how people think about objects, how they classify them, and how they use words. For example, by getting people to stop calling whales fish or start calling certain acts misogynistic. Now, my goal here is also to make changes. I should add that the goal here is also to make changes to shared conceptual practices. But as we saw from two principles, these constrain categorization for all humans. So what we will get is automatically shared. Okay, so from conceptual engineering, we all know a certain implementation from social conceptual engineering projects or conceptual engineering projects in general, and implementation challenge arises. Namely, if we want to conceptually engineer a given social concept that is relevant in people's everyday lives, so these are the social concepts that I'm kind of interested in, or normative concepts, then how do we go about in doing that? My claim here is that there are two important lessons for the constraints and avenues for the implementation of conceptual engineering projects of social concepts that we can draw from the history of the psychology of categorization. And here are the two lessons. The first lesson is that conceptual change requires world change, and the second lesson is that conceptual change requires verbal change. So let me defend each in turn. So what is one of the core insights from Roche? Basically, what we know now is that we should categorize the world the way we do, given the two principles. So given the efficiency constraints and the bundles of co-occurring features we receive as perceptual input. In other words, we know that certain perceptual input, together with the desire to maximize informativeness while saving cognitive resources, just will result in certain conceptual practices rather than others. and the formation of certain concepts rather than others. So given the efficiency constraints and the bundles of co-occurring features we receive as perceptual input, we can predict what kind of basic level categories we will form and use. Particularly concepts or basic level concepts will be such that A, members are similar to each other, B, distinct from non-members, and C, A and B must reflect real statistical patterns in the world. So the consequence of this is that novel classification and induction practices won't be implemented if the real world input we receive makes the adherence to old classification practices align better with the principles of categorization. So if our ameliorative aim is to change a given classification practice, such a change will be inefficient for the purposes of information maximization if, due to structural and other factors, the classification system is not exposed to the corresponding data bundles. And let us look at a specific example. Let us look at the conceptual practice associated with women, or a fragment of it. So to exemplify a fragment of this conceptual practice, look at this following example from Banerjee and Greenwald. A father and his son are in a car accident. The father dies at the scene, and the son, badly injured, is rushed to the hospital. In the operating room, the surgeon looks at the boy and says, "I can't operate this boy. He's my son." So from this, we can extract, again, a fragment of the associated practices with the concept woman. What's going on in the example is that there's, a certain cognitive dissonance, because maybe some of you, but in general, many people assume that the surgeon is a man. However, we know the father just died. So then we think, how is it possible that it's his son? Notice, oh, wait, the surgeon can also be the mother. So again, from here, we can associate a couple, extract a couple of associated practices with the concept woman that we likely don't apply it to surgeons, or you can take other examples if you like brilliant formal philosopher and so on, that if we apply woman, we likely don't apply surgeon. So this is likely not an induction that we make, or brilliant formal philosopher and so on. But on the other hand, if you hear a story about an empathetic teacher, it might be quite likely that you apply the concept woman, even if you don't know the gender of the teacher. Now, notice that these sorts of inference and categorization patterns, as we all know, often take center stage in much public social justice discourse, and much effort is put into changing them. Just think of projects like debiasing seminars in universities and so on. However, a crucial lesson of Rush's two principles is that efforts in conceptual engineering must be preceded by corresponding changes in perceptual input. So if we get a high amount of man surgeon bundles, but not of women surgeon bundles, the surgeon features will be distinctive of men and not predicted of women. Notice that the binary language I'm using here comes from me operating with this basic level concept idea, and as has been shown, these are the basic level concepts we use in gender classification. Now, so that we don't apply woman in the example I just have shown you, therefore makes sense from the perspective of the principles of categorization. Now, what is the upshot of this? It's just that conceptual change must be accompanied by social change. And that implementation proposals that don't prioritize external changes are likely to be cognitively unfeasible. So in the slogan, as Johnson puts it in her paper where she makes a similar point for implicit bias and machine learning, representation matters. Okay, so this is the first lesson. But this is not the only lesson. I now want to defend that implementation requires verbal change. Now, how do I argue for that? Notice that given that we are governed by the two principles, the conceptual practices we adopt as a matter of fact as a community indirectly communicate important information about category members and alleged non-members that go over and above the information we directly associate with the category in question. So for example, by classifying two people with a basic level label L, we don't only communicate that they're both L, but also that they're sufficiently similar in important respects as to warrant classification under the same basic level concept. And this, so the labeling practice with basic level labels gives agents meta-evidence about the existence of similar features and prompts them to search for similarities underlying the co-classification, even if those aren't immediately obvious or not existent at all. Similarly, by classifying two people through distinct labels, we communicate that they're sufficiently dissimilar in important respects as to warrant the classification under different basic level concepts. And again, this primes agents to search for dissimilarities in order to make sense of this classification. And if there aren't many dissimilarities, to prioritize the ones there are, to overrepresent them probabilistically. So here, look at this example, American. There's a clear sense in which the category isn't very distinct from other national base level categories, such as Turk, German, Peruvian, or any other national base level category. Now, these categories are clearly more like each other than, for example, tigers and elephants. But our naming practice tells us that there are many intra-category similarities and inter-category differences. So we look for them and overrepresent them. And the result of that is that we will probabilistically misrepresent features to be much more distinct and common than they really are, leading to the formation of, for example, national stereotypes and other dubious conceptual practices. In fact, it has long been established that social base level categorization reduces perceived variability within social groups. Similarly, we also know that naming practices have a stark effect on perceived group homogeneity and outgroup distinctness. Here we can also see why certain debates of social groups or efforts of social groups to change naming practices matter. So the upshot of this is that naming practices play an extremely important role in the construction of the perception of similarities and dissimilarities, and correspondingly the dissemination of social stereotypes that serve as markers between different categories that are otherwise very similar. So in sum now, we have two lessons again. First, that conceptual change of social concepts requires social change. And second, that naming practices play an extremely important role and also play an extremely important role in eliciting conceptual change. Therefore, social change must be accompanied by the corresponding change in naming practices in order to effectively elicit conceptual change.